Hello, my friends of Hatari Labs. My name is Montoya. Please welcome to this tutorial where we are going to install the parallel version of Modflow 6. That is, we are going to run it under a Docker image, and then we are going to run it with an application with some application examples. Okay. So first of all, what you need to have is Docker desktop for Windows. Desktop for Windows. Okay, so you need to install Docker. Okay, so you just download it. Okay, and install it. Great. Okay, so and then you have to store. Okay, so it will, I mean, after you have installed, you will have something like this and says engine running. Okay, why we need engine running? Because actually we are not going to work with this one. We are going to open PowerShell, and here on PowerShell we are going to type Docker, and this is we are going to access Docker through here. We are going to access Docker through here. So, and the process is really simple, so actually you are not required to do much. So we are just going to run this line, and this line will download the image that we have created that has the example, that has the installation, and that has the executables, okay? And it will run under a Jupyter notebook on port 8080. Okay, so we just type enter, okay, and it will pull the image. Okay, so actually it's pulling the image. Okay, and once it's finished, but it will only pull the image just once. Okay, so for the next time that you run this, actually no image will be pulled. Okay, so mhm, and it will extract as well. Okay, so let's wait a little bit and let's be patient. Okay, and now it will launch Jupyter Lab. So you have to open any browser, and then you just have to go to localhost 8080 okay, and the password is Hatari Labs. Great. And this Jupyter, okay, has already the executables, and it runs with PESC and MPI, okay, that are two requirements of the parallel version of Modflow 6. So for example, and then here we have example model, okay, that we are going to run under the two versions. I mean, the normal MF6 and the parallelized version of MX6. So you will know, you will see how they are, I mean, work, how they work and how they are run. Okay, so we open the terminal, okay, P with print working directory, okay, so we are in the sample model. Okay, and in order to run the MX6, okay, the MX6 is already an executable here, so you just have to call it in this way, and then you MF6 mfsim.num. Okay, you can put just MF6, but in the fact it's mf6.num, okay, and it will run the model, and the model will run in 3.32 seconds. Okay, and then we can run this under, okay, so CLS clear. Okay, we can run this under the parallel version. Okay, so for the parallel version is npexec. Okay, we can select the number of cores that we need. So in this case, that really depends on your computer and the number of cores. Okay, so I wanted to use three, but in fact they don't work this way. So I maybe I can just work with four. I wanted to use four, but maybe, I mean, actually I know that it works with two. I will try three. Okay, so mf6 parallel. So this is the executable. Okay, and then we can mfsim.num. Okay, so we run this mx, and they say, okay, no, you cannot do it with three cores. So clear, I will run it with just two cores. And this is because we are in Windows, okay? So because actually, well, to tell you the truth, in Linux, I actually ran it with all the cores and it broke. So I think that you have to, I mean, well, there is more research to be done. Okay, so just two mf6 dot parallel. Okay, rate mfsim.num. Again, clear mpi exec mp4 mx6 parallel mfsim.num. Okay, that's it. Wow. Oh, sorry. Okay. I'm making so much mistakes. So once again, clear, and then just copy paste from my paste. Okay, so image with just two cores, we run this. Okay, and it's running. Okay, so it's actually splitting the model and it's running for the first core and then for the second core. So that is why you see the same twice, and the first core has finished in 3.866, while the other has finished in 3.874 seconds. So really similar to the original one. These are not heavy models, okay? So actually we cannot define that these models are going to be okay, based on which size actually you are going to see a decrease on the time, on the simulation time, or a better performance due to parallelization. This was just more an example that shows you with a great percentage of success how you can run parallelized version of Modflow 6 with the executables and with an applied case. Okay, so I hope that this tutorial will be helpful for you, that it will give you and you can explore from them other applications on that you want to apply this for bigger models, or you want to apply this to, yeah, mostly for bigger models if you want to see which will be the decrease in the simulation time with the parallelized version of Modflow 6. I strongly recommend that you work in Linux, because actually in Linux is where you are going to have the fully potential of this parallelized version. Okay, so my name is Saul Montoya. Great to have given you this version, this tutorial, and hope to see you in coming courses, webinars, and so on. Just to remind you that we have a FlowPy course that is coming, and this FlowPy course is going to be online, and it will be a complete program that will give you all the tools, all the Python tools and all the FlowPy tools to develop apply groundwater models with Python and FlowPy. Okay, thank you for following and see you next tutorials. Bye bye.